Hey guys, we're going to do the second foldable. Okay, so this is about sine, cosine, and tangent. So let's take a look. The sine, by definition, is the ratio of opposite over hypotenuse. So let's see, opposite this reference angle A is side little a, and opposite the box or the right angle is the hypotenuse, and this last side is called the adjacent side. So here we notice that the sine of A would be the little letter a, and C the hypotenuse following our formula. Okay, what is the cosine of an angle? Well, the cosine of an angle by definition is the adjacent side over the hypotenuse. Okay, so if this is our reference angle, again, this is opposite that. Opposite the box is the hypotenuse, and here's our adjacent side. So I'm going to plug in B where I see adjacent and C where I see hypotenuse. Okay, and now tangent. So tangent of an angle is the ratio that a right triangle makes with the opposite side and the adjacent side. So if I label here the opposite, and opposite the box is the longest side, the hypotenuse, I'm going to use my opposite side, well, that's A, right? And my adjacent side, that's B. And those are my three trig functions. Okay, so now on the inside, we're going to practice using those trig functions. So if my reference angle is 58 degrees, this is opposite, and opposite the box is the hypotenuse. So that's why this makes sense that the sine of 58 is opposite over hypotenuse. So the sine of 58 is, I'll just give myself a little bit more room. Opposite, we labeled the x. Hypotenuse is the number 17. Okay, so to solve for x, we want to multiply by 17 on both sides. So let's go ahead and do that. And this 17 would cancel. We get x is equal to 17 times the sine of 58. Nice. Okay, so figuring what that is, where's our calculator? There it is. So the sine of the 58 times 17. So we have the sine of 58, which is 0.848 times 17, 14.4. Now let's see if that makes sense. So I'm looking for a number less than 17. I got it, 14. All right, now what about this one? Well, if my reference angle is 49, this is opposite my reference angle, and opposite the box is my hypotenuse. So here, the sine of 49 degrees would be 52 over x. Now my x is on the bottom, and I'd like to get x by itself on one side, so I can do what we call the Lynch swap. There we go. Okay, so x is equal to 52 divided by the sine of 49. So let's figure out what the sine of 49 is. I get 0.7547. 0.754. Right, 547. All right, so I want to take 52 divided by that number, 0.7547. 52 divided by 0.74. 75. I messed that up. 52 divided by 0.7547. All right, and I got 68.9. 68.9. Now we plug that in and we ask ourselves, does that make sense? Well, yeah. The hypotenuse is the longest side, and it's a little bit longer than 52. Okay, now that we solved for the sides, let's use the inverse function to solve for the angle. So here, if this is our reference angle at x, then this is opposite that reference angle, and this is opposite the box. So notice it makes sense that we can use the sine function, right? So the sine of x is the opposite we labeled 37, and the hypotenuse 44. So now, what do we need to do? Well, we need to find the inverse sine of both sides so that we can get x by itself on one side. So, right, so here, the sine of x, we took, and then this was our fraction. So, algebraically, we end up getting the inverse sine of 37 over 44. All right, so 37 over 44. Enter second sine. Okay, I got 52, and they want me to round to the nearest degree. So 57.2 would round to 57. And when we plug that in, we see, yep, that's a number less than 90, so that looks like a number we're looking for. Now, some students might need to write in the calculator instructions. They're like, I didn't get 57.7. So here's what we typed in. We typed in 37 and hit the division button, and 44 and hit the equal button. So we figured out what is 37 divided by 44. Then we hit this second button. That's our solve for the missing angle button, and then sine. Okay. So how can we do the same type of thing, but with a different trig function? So let's take a look. If my reference angle is 67, and I go opposite that, there's nothing there. If I go opposite the box, I get my hypotenuse, and my leftover side is the adjacent. So notice we need the cosine of 67 here as the ratio adjacent over hypotenuse. Okay, because I have x to plug in for adjacent and 15 to plug in for hypotenuse. So the cosine of 67 is x over 15. Okay, so to solve for x, I'm just going to multiply 15 by both sides so that the 15 would cancel, right? So the left side says 15 times the cosine of 67, and we have x. So what is the cosine of 67? Looks like 0.3907. Okay, and we're going to take that answer and multiply by 15. Times, see that changed the number, so I gotta retype that in. Cosine of 67 times 15. Cosine of 67 times 15. All right, 5.9. All right, looking in my picture here, yeah, that makes sense. My hypotenuse is the longest side, so I was looking for a number less than 15. Okay, now let's looking at this. Again, if this is my reference angle, there's nothing to the opposite side. Opposite the box is labeled x, and that would leave my adjacent side 21. So the cosine is the function we need, and the cosine of 34 is opposite over hypotenuse. So the cosine of 34 is, oh, what did I do? No. Adjacent, right? Okay, so the cosine is 21 over x. So I need my Lynch swap here, right? I need x there and the cosine of 34 down there. Okay, so what is the cosine of 34? 0.829, okay? So x is equal to 0.829. 12 divided by 0.829. 12 divided by 0.829. 14.5. 14.5. So let's take a look. Oh, that didn't work. So let's try that again. 21 divided by 0.829. 21 divided by 829. There you go. That makes sense. 25.3. 25.3. So note that I made a mistake there. But I was able to catch it because I'm looking for a number bigger than 21, right? My hypotenuse is the longest side. Now, how can we use the cosine to solve for the missing angle? Well, we do that when there's nothing in the opposite side. So we have something here on the hypotenuse, and we have something here on the adjacent side. So we're going to use the cosine of a function when we have the adjacent, and we have something to plug in for the hypotenuse. So the cosine of an angle is 14 over 18. All right, so we're going to take the inverse cosine of both sides. And put what was already in there. All right, and this side turns to x, and this side. 14 divided by 18 inverse cosine. 14 divided by 18 equals second cosine. So I get 38.9. That'll round up to 39 degrees. So plugging it in, that looks right. I'm looking for a number less than 90, right? If you're needing some help on what steps I took, I hit 14 divided by 18 equals. And then I hit that second button and then the cosine. Okay? Last one, let's use the tangent function. So why would I need the tangent function? So notice I have something to plug in for the opposite side, but nothing for the hypotenuse. I do have something for the adjacent. So the tangent of an angle is opposite over adjacent. So tangent of the angle 38 is opposite x over adjacent 10. Now we can solve for this here by multiplying both sides by 10. So we get 10 times the quantity, the tangent of 38 equals x. Okay, so let's find out what the tangent of 38 is. We find the tangent of 38. We get 0.781. 0.781. So when we multiply that by 10, we get 7.8. Okay, so when we plug this in, we're like, oh, okay, yeah, I was expecting a number around 10. That's another leg. And since this is a small angle, I was expecting something smaller than 10. That's what I got. Now looking at here, our reference angle is 54. Opposite of the 54 degree angle, we have 17. And the adjacent side, we have x. The hypotenuse, once again, is blank. So that's why we're using tangent. We see here we can swap these, right? These can be swapped. So I can list the x here and then put the tangent of 54 on bottom. Okay, so let's figure out what the tangent of 54 is. 54 tangent, 1.376. All right, and I want to do 17 divided by 1.376. 17 divided by 1.376. 17 divided by 1.376. Okay, and I get 12.4. So let's see what that looks like. X is 12.4. And that looks good. Yeah, I was looking for a number around 17. This would be 36 degrees. So yeah, this would be a number less than 17. Okay, last one on this sheet. Now, how can I use tangent to solve for a missing angle? Well, we do that when we have nothing in the hypotenuse, but we have something on the adjacent side and something on the opposite. So again, the tangent of an angle is the adjacent. No, what am I saying? Well, I'm crazy. Too much work today. Okay, opposite over adjacent. So the tangent of an angle is 11 over 18. Now, if I find the inverse tangent of both sides, on this side and this side, I notice I get x is the inverse tangent of 11.18. So I'm going to type in 11 divided by 18 equals, and then second tangent. Okay, so let's do just that. 11 divided by 18 equals second tangent, 31. We're going to round to the nearest degree, so I get 31 degrees. 31 degrees. Nice. Thanks for joining me, guys. Check out the next video for the last foldable.